So why did the ice cube that was placed in the metal pan melt much faster than the ice cube that was placed on the chopping board? Let's consider the four objects that were used in the demonstration. So there was a chopping board. It had a temperature of 22 degrees, or whatever room temperature was. It's an insulator, so if it was wood or rubber or cork, that's an insulating material, not very good at conducting thermal energy. And that object would have felt relatively warm when you touched it. When the ice was placed on the chopping board, it also melted very, very slowly. Then there was the metal pan. It was at the same temperature as the chopping board, so room temperature. Metal, however, is a good thermal conductor. The metal pan felt relatively cold to the touch, and the ice cube melted very quickly when it was placed on that metal pan. The other two objects were your hand, so its temperature would have been around body temperature, so 28 to 37 degrees, and the ice cube, which straight out of the freezer would have been less than 0 degrees Celsius. So initially when you placed your hand on the chopping board, your hand was relatively hot and the chopping board was relatively cold. Your hand had a higher temperature than the chopping board. So when objects of different temperatures come into contact, thermal energy will be transferred from the hotter object to the colder object until they reach the same temperature, which is what we call thermal equilibrium. In this case, thermal energy is moving from your hand into the chopping board. This is shown on the diagram with those red arrows. Now looking at the metal pan, there's still a difference in temperature. So your hand is relatively hot compared to the pan. What's different in this case though is that metal is a good thermal conductor, and conductors are able to transfer thermal energy much faster than insulators. So those large arrows represent that heat transfer at a much faster rate. So what we sense as hot or cold isn't actually the temperature of the object we're touching, but the transfer of heat from or to our hand. In this case, our hand is losing heat very quickly to the pan, so it feels quite cold. So when the ice cube was placed on the chopping board, we also had a difference in temperature. So the chopping board was relatively hot compared to the ice cube, which was relatively cold. So with a difference in temperature, thermal energy will be transferred. And as always, thermal energy will move from where it's high to where it's low. So from the hot object to the cold object. The metal pan and the ice cube had that same difference in temperature. The pan was relatively hot, the ice cube was relatively cold. However, the metal pan is a good thermal conductor, so it was able to transfer thermal energy much more quickly into that ice cube. And we could see this because the ice cube started to melt almost immediately. So the ice melted much faster in the pan because metal is a very good thermal conductor. It transfers heat much more quickly than objects that are insulators.